Alright, ladies and gentlemen, let's look at this problem. Now, in the actual printed class notes, they give you a lot more information. They talk about the initial velocity, different things. What is the most important from this problem is this formula, this function actually, which is called a position function. S of t equals the opposite of 16t squared plus 120t plus 80. Tells you where this object is located above the ground at any time. And I believe the units, height is measured in feet and t is measured in seconds. And again, the initial problem told you that if I was putting this on a test, I would make sure your units were very clear. Okay, determine the time at which this rocket reaches its maximum height and find what the maximum height is. Okay. Here's the underlying thing to this, the first part of this problem, because I'm going to do two videos. This problem continues, but we're going to do this part right now. This position function is a parabola, and it opens down, because you know when a is negative, the parabola opens down. Now, by no means am I drawing an accurate sketch, but this is a parabola opening down. Where is the maximum going to occur? Well, hopefully, it's pretty clear that the king of the hill is the vertex. So once I know the vertex, I can answer this question. Okay? Well, we know how to find the vertex. Now normally we say x equals the opposite of b over 2a, but since this problem is using the letter t for input, let's adjust. So t equals the opposite of b over 2a. So t is equal to the opposite of b is 120. 2 times a is negative 16. Okay, what's going to happen? A negative and a negative become a positive. And if you take your calculator, 120 divided by 32 is going to work out to 3.75. Okay, so the first coordinate of the vertex, t, is 3.75. Now, to get the second coordinate of the vertex, we plug that in to the original function. So we find s of 3.75, which would be the opposite of 16 times 3.75 squared plus 120 times 3.75 plus, I'm running out of room here, plus 80. And I did this ahead of time on my calculator. This, when you do all this on your calculator, and by the way, on your calculator, this is just real easy to do. Just get into the calculator mode, you know, not the graphing mode. And if you're in the graphing mode and you want to get back, you just hit second function, quit. That takes you back to calculator. You type in the opposite of 16, left paren, 3.75, right paren, caret 2, plus, and so on, and then hit enter. And you'll get the answer 305. So, 3.75 is the value for t. That was the input. 305 is the output. That's s of t. So here's what I know. The maximum height is the output. Remember, input is time. Input is time. Output is height above the ground. So the maximum height, the maximum y value is 305 feet, and it took 3.75 seconds to reach it. Alright, so there we go. The maximum height is 305 feet, and it took 3.75 seconds to reach it. Time is input, height is output. So basically, all you had to do on this worded problem, this model, this position function, was apply the vertex formula and then interpret the results.